Well, hello again. The mornings are still too cold here to be running back and forth between the house and the garage all the time. By the time it warms up, half the day is gone. Well, I don't want that to happen. I'm going to use the half a day to work on this. And I'll be doing that. I only got a couple more videos, I hope, and that'll be it. So let's get to it. Electrolytics. We're going back to the electrolytics. I don't know if anybody noticed or not. I sure did, and so did one other person. But on the schematic, we're going to do a little schematic work today. Not much, not enough to bore you or anything like that. But if you look on the schematic, we go down here to the parts list, resistors, capacitors, condensers, which is another word for capacitor. We come down here, and it says electrolytic capacitor 0.8. Electrolytic capacitor 0.8. Now the other person that noticed that, he didn't think I noticed it. Well, of course I noticed it. But it wasn't ready to bring it, to light. And interestingly, no one else ever noticed it though. Anyway, okay, now I told you that these were going to be I called them 8 microfarad capacitors. So why did I call them 8 microfarad capacitors if they were 0.8? Well, because which are they? Are they 8 or are they 0.8? Well, let me put it to you this way. You are never going to find a 0.8 microfarad capacitor rated at 350 volts, has an electrolytic, and an old radio like this. And no radio like this. I've never seen any old radio that had 0.8 microfarads. 0.8 would be like about that big, Yeah, that's no good, okay? And you can see right here that the old boy that replaced these in the radio a long time ago, let me see if I can get it. He replaced them with, get this light out of the way where we can see something. He replaced them with 8 microfarad at 450 volts. Both of them are the same size. Let's go back to our schematic. Get my pencil. What do I do with my pencil? I can't do anything without my pencil. Ugh. Okay, back to here. You'll see that the 0.8 here and here was a mistake. They should have never done it like that. So I'm going to have to get rid of these 2 points. Had I just started out in radio repair and I saw this 0.8 on there, I would look in here and I would see where it said 8 microfarads on those capacitors. And I'd say, uh-oh, somebody put the wrong capacitors in there. No wonder this radio's not working. That's what I would have thought right in the beginning when I started working on these old things, because there were so many differences in working on an old radio from what I had already known and worked on myself in the past. And it was like, well, and I had been told that, some schematics were totally wrong. So I'm thinking, I would have thought, well, this says 0.8. This has either got to be wrong or it's got to be right. Well, which is it, And if I would have gone on the antique radio forum and said, I need some, where can I get 0.8 microfarad electrolytic caps? They would have said, what? What planet are you from? Anyway, let's go to the capacitor itself, okay? What does it say on the capacitor itself? If you're lucky, it'll say something. Sometimes they don't. This one says 8 microfarads at 350 volts. I guess that pretty much clears it up, doesn't it? So, yeah, sometimes you're going to see little boo-boos like that on schematics. It's not the end of the world, okay? We straighten it out. A better question to have asked the antique radio forum would have been, hey, look, my schematic says 0.8, and the actual, electrolytic says 8, or it says nothing on there. Which is that right? It's 0.8, right? And yeah, they would have said, no, of course not. It's 8. Put 8 in there. So I hope you learned something from that little fiasco. All right, now let's take a look at the chassis now, down in the bowels. The next thing I'm going to do is put these electrolytic empty cans back in there, and then this thing right here, and this thing right here are both connected together with all this other mess of stuff here, from the positives of the electrolytic to this. This is a 20K resistor, and it runs back over here. You'll see the green. See that green right there? That's a 25K resistor. This is a 20, that's a 25, and they all come up and connect to this baby right here, to this one right here. Okay, and then of course this one over here also connects to it from that side. So this whole mess right here is connected all together. Come on, get a little focus here, camera. Let me get this light up out of the way, that might help. Come on, come on. There we go, okay. This thing here is connected to this thing, which is connected to the caps, which is connected to a 20K resistor, which is connected to a 25K resistor. Well, I'm about out of breath saying that. Let's look at our schematic and see if any of this is right. You know, does one of these have to be grounded and the other one not? I don't know. Remember the gyration we went through with this thing here? Is this supposed to be grounded? Well, I can't remember. We'll have to go to the schematic and take a look. Alright, here's our electrolytic capacitor, C13. And down here is C18. Now the positives are connected together, which we can see right there. See it? And if you look up there, our two positives are in fact connected together. There's the two leads soldered to this thing right here. That little booger down there. Need a little more light there. There we go. Now we can see that the two positives are connected to there, and there's also this 20K resistor connected to the same mess. Now we got to find the 20K resistor. Well, if we sweep to the left here, remember, the schematic is either north, south, east, or west. If you look at it that way, it's a breeze to follow, okay? Now we're going to go west from the two connection points on these positives, and we're going to run into a resistor here that it says, looks like R5. Some of these schematics are very difficult to read. I'm going to go over that here in a second. Okay, we come over here to R5, and we come down, we see R5, 20K resistor. Exactly right. So that's this baby right here. Now we got that other one with the green end way down in there. That's a 25. Where's the 25? There it is right there, R4. Those are the two connected together. So we got a resistor connected to a resistor, which is what we have. And those two are run over and they connect to a positive on the electrolytic, which comes over to another positive on this electrolytic. Well, everything's cool. Now, are there any grounds there? Do we have to worry about a ground? Nope. No grounds there at all. So we don't want to ground anything. There's grounds everywhere else. But in this particular line of connections, there's no ground, okay? You can follow it out anywhere. You'll not see a ground. So what do? Once again, we're back to our electrolytic capacitors, and we know that we want to hook up these two things right here and right here. And apparently all they are is solder points, just like this big old round thing was. The two solder points. But this one here was connected to the outside plate. So they had to put an insulator in there. This one was connected to the inside plate, which was all the way down at the bottom. So the question is, if these two are not supposed to be grounded, are the capacitors grounded down here at the end? Remember, this one here was attached to the chassis. Alright, that mess is shined up on both of them. I just took them out to my wire brush on my bench grinder and just cleaned them up a little bit. They're a little rough, but who cares? Okay, I've got the black lead is connected to the outside plate to the chassis, and then I connected another one from that same electrical point, and I've got it connected to my negative lead on my multimeter. I could have connected it to the red. It doesn't matter when you're measuring ohms. Either way, some people think, oh, if I don't get the negative hook to that, I'll get the bad reading on resistance. No, you won't. Okay, here we go. I'm going to test it and see if we got continuity now. Let's go down here to the bottom. I want to make sure I got continuity all the way through. Yes, we do. All right, now let's go to where I want to hook the this thing right there, and then we'll do the second thing on the other electrolytic capacitor, so I know if I can hook that to it. Remember, neither of these are to be grounded. So let's go down here and see if I put this thing in the chassis, which is what this is simulating, this black lead being connected there. Let's see if I can get any continuity here at all. Nothing. Nothing. Fantastic. I can go ahead and connect up this one right here with no sweat. The reason being is, first of all, the center plate, or the other plate is on the inside here, is not touching anything, and it's insulated from this right here with this big old thick washer. Pretty cool, huh? That's a big old thick washer, okay? If there's ever any doubt, you can always take like a nut off of here and put extra, fiber washers in there and make the same kind of continuity test. All right, now let's test the second one. All right, here we go with the second one. Nice tight. Nothing at all. Do we have continuity here? Yes, we do. Again, nothing here. Okay, that takes care of that. I can now connect both of these things in here. Let me get the light out of my face. We can connect both of these, this thing here and this thing here, right to the end of these things because they're isolated from ground, both of them. Now, that just leaves us with this little baby right here. What am I going to do about that? Ooh, have I got a plan for that? Because this thing here, we do not want it to be connected to ground either. Of course, it wouldn't make any difference the way I'm connecting it up, but I want that thing out of there. I don't want anybody to be surprised by the wrong connection maybe years from now. I'm going to get rid of that thing. I'm going to show you how easy it really is, hopefully. Everything is connected up. I will have one more thing to do after this, but right now I want to do something with this. I do not like this mess. We're going to get rid of it. We're going to put a terminal strip in there, which gives me an opportunity to show our new folks the difference between an isolated and a non-isolated terminal strip. This is an isolated terminal strip. If I put a screw down through there to the chassis, the only thing grounded is going to be this little tab right here. Now you could turn it into a ground if you wanted to run a wire from, say, this hole over to this hole. I've done that a lot. Then I turned the long one into a grounded terminal where I could hook more than one wire. That worked pretty good. But initially, when you get them, they're isolated because they're isolated. This thing here is no way is that going to be connected to ground. Okay, now here's another one that's isolated. It's a vertical terminal strip. It too has the grounding strap or the connection strap to chassis separate from the other terminal, completely separate. Okay, and again, if I wanted to turn this into a ground, or I just would run it, for say, like a wire from here to here, and that would automatically make it a ground, and it would give me more space to hook more than one wire. That's just a little trick, okay? Now here's your non-isolated grounding strip. Well, I'll tell you what was interesting. One time when I was working the antique radio forum, I brought up a question about isolated and non-isolated. I think I needed to know if anybody had an isolated an isolated terminal strip. And all of these guys chimed in and said, what's a isolated terminal strip? Nobody seemed to know that day what an isolated terminal strip was. I thought that was interesting. Anyway, this one here is non-isolated. Why? Because once it goes to ground, we still have a strip right here, okay? It's not totally isolated from ground. If we put this here, this one is not. So I could still use these, but this one, in order to make sure nobody solders to a ground, it doesn't need to be grounded, make a mistake and not realize it, you would have to cut that off, okay? Some guys just bend it all the way around, keep them from using the hole too. So it depends on what you want to do. Just know that there is a difference between an isolated and a non-isolated terminal strip, okay? Well, here's what I have decided to do about that soldering tab setup they had down here. I cut this off. Then I went ahead and put this terminal strip in. It's a tall one with a single connector on top, or a single solder point. Then I took what was left of the original soldering tab, and I've got it bent up against here, right here. It's only there as, to keep things stable. That's all it's there for. It has nothing to do with ground or power, none of that stuff. It just keeps things stable. And now I'll go ahead and solder the two together. Let me get you a little closer look-see here. Now I've got some flux between them, right here, paste flux, which will make it a little easier to solder, I hope. Alright, that's soldered up real nice. It's really good to go now. Nice and solid, okay? Actually kind of gives me a little more room in there too. You know, I still have the option of spinning this thing around clockwise and bending this over out of the way if I need more room, but I don't see the need for it right now. Alright, let's move on to the capacitors. Alrighty, what have we got here? Well, we've got two electrolytics, of course. They stick out like sore thumbs, huh? But your regular paper caps is 1, 2, 3, 4, 5, 6, 7. We have 7 of them to change out, not counting these. Alright, let's go to the schematic. Alright, looking at the parts list, we have these 0.1s. Got a lot of 0.1s, so we got 1, 2, 3, 4, 5, 6. There's a 0.5, 7, 8, 9, 10. Say what? Let me count that again. We only have 7 in the chassis. We got 1, 2, 3, 4, 5, 6, 7. There's a 0.05, 8, 9, 10. You got 7 in the chassis and 10 on the parts list. Now let me tell you something. If a new person saw this and saw that, this would boggle his mind. How can this be? How can I have 10 capacitors here and only 7 there? Did they make a change? Did they make an update? Did they eliminate them? What's the deal on that? Well, I'm fixing to tell you. I ran into this years ago when I restored a Spartan radio model 67. Same situation. The only difference was their capacitors were covered in a black tar from the factory. And then they stamped in red, in that sort of black tar looking thing, the value of the capacitors. Well, of course, over the years, the black tar flaked off and most of the values were gone, which was a real joy to look at. What we have here, people, are multiple caps. This one right here actually has 2 capacitors inside of it, and so does this one, and I believe this one down here. So that's 6 of them right there. And then we'll have to take a look at it a little closer. We'll start eliminating these things, and we'll know which ones have the double caps in them. The giveaway is this, see how this thing is anchored to the chassis right here? The giveaway, when you see a capacitor like this, with a band around it, and fastened to the chassis, it's almost always a double capacitor. It looks like one, but it's actually 2. Now let's start checking these things off on the parts list. Let us find here our, now each of these capacitors has a number, a part number associated with it, okay? All your mica capacitors and your paper caps, your electrolytic, they've all got a, we're lucky, they're all on this schematic, sometimes they're not. So let's start with a 0.05, the part number is 122. It would be a fairly small one. There it is, 122. So that takes care of that one. Let me check this baby off. Where are you, you little turkey? There we go. Okay. Now let's find another one here. These are all mica, 0.1s, 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 0.1s. I thought there was a different number here. 0.1, 0.1. Okay, what we have here now are, this is a 120 right here, which is a 0.1, and another 120, which is a 0.1. So they obviously are single caps. So let's try to find a couple of 120s. Let me see. Let me dig around here and I'll come back. Alright, here's one of the 120s. There's the other 120. They, of course, put them in so you had to spin the cap around to find them. Alright, let's check those 2 off. 120, 120. Alright, that should leave us with nothing more than the double capacitors, which is 2, 4, 6. I got another one down in here. That's a 111. Let's find out what that is. 111. There it is. That's a 0.1, stands by itself. That is not a double capacitor. So that's a 111 down there at the bottom. So that should leave us with two. This one has a band. This one here has a band. See it down in there? Okay, got that silver band in there. So we should have 2, 4, 6. Let's see if we got that many left. Well, there you go. There's 4 of the 6. All 118-1s. And C16 17 are also 118-1s. 4, 2, 6. Okay, now we know what we have to do. So now we have to make a big decision. Big decision, folks. Which one should we change first? I've always, the way I do it, guys, you do it any way you want. I like to deal with the hardest ones first and work out to the easy ones. Now this is going to be easy. This is going to be easy. This thing here will be very easy because one connection's right there and the other one's over here. The one down in there is going to be the most difficult right here. But it won't be difficult if I disconnect one of these electrolytics. So let's chop one of them away and see what happens. Alright, here goes. We're going to cut that. I'm going to leave myself some length there. I'm going to need length. The way I change capacitors, I need that length. Now we'll move this out of the way. Should be a whole lot easier than that. And then now we can get to that one down there. No problem at all, okay? You can always make life easier on yourself. This will be the first one I change. Then I'll go to this one. I'm going to do these 0.1s last. I'm going to do this one, and this one, this one, this one. Get those 4 out of the way first. I'm going to change this one first to show you how I change capacitors. And it'll be exactly the same for this one and this one and this one. Alright, so it won't be any guesswork. First thing you got to do is we have to cut this and leave some length. This is a 120. Now 120 on here it says is a 120. Where are you? It's a 0.1. 120 is a 0.1. Alright. So we'll go ahead and we shall, what one was I going to work on here? I guess it's this one here, yeah. I need to leave some length. So we'll leave some length here. And you know, this insulating thing right here, try to save that if you can. So we'll get close up to the capacitor on that. Oop, I cut the wrong one, I guess, didn't I? Yes, I did. Hey, that's going to happen. That's not a problem. We'll fix that too. Okay, let me give me some length here. I want this length here. I thought that was there. It looked like it could come down, went right down to this lead, but it didn't. Hey, we do not worry about such things, right? No, we don't. It's all the same connection, by the way. So what I'll do is I'll splice a wire on here, run it up to there. Not a problem. I'll tell you what, why mess with this big old clunky dog bone? I measured it out and it measures almost 27K. It's supposed to be 20. So that's far enough out of tolerance to make me go ahead and change it. So let's clip it on out of there. You know, for the way I change out capacitors and resistors, I need both of these stubs here. Okay? And I have one down here for the capacitor. This one right there. Get it out of there anyway. But boy, they sure didn't give me much to work with on this resistor. Look at that. They soldered it almost directly to it. I'm going to try to heat this thing, see if I can pull it away from the body of this resistor. Probably not, but I'm going to give it a try. Well, son of a gun, I was able to actually do that. So now I got some lead to work with. Let me go ahead and pop that baby off of there. We'll try to get that replacement. This is a replacement. Look at the difference in size, huh? Half watt, 20K. Red, black, and orange. Big difference in size, huh? Both of these are half watt. Let's see what this one reads before we put it in. 19.9, that's pretty close to 20K, isn't it? Yes, it is. Good to go. I've shown this about 100 times in my past videos, but what you do is you take your resistor, this is the way I do it. I like to solder what I call the coil method. I learned it years ago, and it seems to work a whole lot better on all of this stuff. Now remember, I have to go between that thing right there and this inner thing right here. So you got to kind of eyeball right about the center where the resistor is going to go. see if I got enough lead on both sides. I'm going from the bottom of the duckbill pliers. So that looks like about right. Right about there is about the middle. Okay, fantastic. Now all I got to do now is just bend the wire a little bit, like so. And then do the same thing to the other side, using this as my first connection point, and then get that wire ready to go too here in a minute. But first we're going to create a coil. We take a very, very small, maybe 0.030, 0.032 jeweler's screwdriver. You don't want a thick one, you want one about this size right here, pretty small. And you lay your bend that I just made, put your resistor next to it, lay your bend over the shaft, and then just start wrapping it around there as tightly as you can. You do it by hand all the way into the end. Now the last little bit, it gets kind of tough on your thumb, so take a pair of duckbill pliers like these and place it around it and finish the last coil with the duckbill pliers. So it looks like that. And even that's sticking up a little bit too much. I'll go ahead and squish it one more time with the duckbill pliers. And then I'm going to close up the last coil again with the duckbill pliers. I'm just going to take the duckbill pliers and squeeze it together. So it looks a little neater, okay? The last thing you do, once you get everything squished together, you pull out your jeweler's screwdriver and insert it from the opposite end, and you use it to straighten up the lead on the resistor. Just grab a hold of the resistor, grab a hold of this, and kind of bend it to where it's a little straighter. And that's what you wind up with if you're real careful and you take your time, practice it a little bit, because now I can just slide it right on up here like so, right on up here like that, and solder it in place. Now, in the future, if the resistor ever has to come off, all they have to do is heat that coil and it slides right off. There's no, you don't disturb the existing joint. That's what we're trying to do here. We don't want to disturb it. So I'll go ahead and do the same thing to the other end. We'll center it up and we'll get it soldered in. And there it is, holding itself in place while I solder. Nothing to it, piece of cake. This one here worked out pretty good because I got just enough leading coming out the bottom, just enough coming out the top. Now if I didn't have enough, all I'd have to do is uncoil one of the coils. It's not that big a deal. You can make it fit. I highly recommend you stay away from that so-called J-hook method of soldering. I never heard of that. And the first time I ever heard of it was when I got on YouTube and I saw people doing it. Anyway, of course, I never saw anybody doing the coil method either. So I guess I shouldn't talk. But this way works real good because you do not disturb the joints and it's easy to remove. Just a matter of, just heating it up, slips it right off. Now sometimes your lead will be much more than you need to make a coil. Just go ahead and make your coil and snip off whatever you think you don't need. 3 to 4 coils is usually plenty. The capacitor has now been installed exactly the same way I did the resistor. Just put a little coil on each end, hooks it right up. Looks a whole lot neater that way, doesn't it? Alright, right now I have already hooked up a new power cord temporarily. This is not the one I'm going to use, but I went out in my shop and in the drawer this was there, so I grabbed it and I hooked it up. We now have everything hooked back up to the switch and to the transformer. Get in the habit of always putting the hot lead to the switch. Doesn't matter pretty much in a transformer outfit, but if you get in the habit of doing that, someday you'll have a transformerless radio and you'll need to do it, and if you don't do it right, you got a problem with a hot chassis. Okay, you don't need a hot chassis. So it's a good idea to just get in the habit right now, if you're ever going to do anything at all, even if it has a transformer, get in the habit of doing it right now, hooking it to the switch, and I'll also be putting a fuse between here and the switch at a later time here. Right now we're going to hook everything up. I've got the, like I said, I got the power cord in, I got a jumper wire between the connection where the electrolytic was. I got it jumpered between the electrolytic and that pin right, and that lead right there. So we're going to flip it over, put the tubes in and fire it up and see if it works. If it works, good. That means everything we did under here is good. If it does not work, we need to go back and take a look what we did wrong. Now, if it does work, and we go ahead and change the rest of our caps and everything, and then it does not work after we get done with that, then at least we know where the area to look at is it's under the chassis, okay? And we won't have to mess around what we did up on top or any, and you know, with on the bottom of the tuner or any of that stuff, because we'll have, you know, we knew it was good before until we messed with the caps. You just kind of take your time to do this. So let's flip it over, get the tubes in, and fire it up. I'll tell you what, boy, it's going to be a long video. I probably should break it up into another one, but I'm going to keep driving on. If you all fall asleep, sorry. These fingers here, before I fire this thing up, these two fingers here, these are your grounding tabs that come up from the bottom. Those wires are hooked down underneath here. They come up and they hook to these two grounding fingers right here. And there's two more over here. You have to make sure they're clean. Right now I've got a piece of fine sandpaper. I took my blade on my knife and I got down in there and I scraped the paint off of, you know, what might have been there, and a little bit of paint off the other side of the finger, and I've got a piece of sandpaper down there and I'm sanding it now a little bit so we have good grounding contact. I'll do the same for this one over here. We are ready. Okay, well, this thing's a little bit stiff though. It's working a lot better than it was though. Okay, I oiled it up on both sides, all the way down in the middle and all the way down there on both sides. Got it looking good. It's working a lot better. So let's go ahead and crank this up. We're going to bring it up again on the variac, and we're going to watch the voltmeter over there. Yeah, we'll watch the voltmeter over there, and we're going to watch the ammeter right here. Okay, let's get a little closer. A little closer. Back up too far. Okay, here we go. Power on. Variac on. Let's bring the voltage up. I'm wondering, I scraped the paint off around the bulb here so I get a good ground. So if we get a bulb, that means we're doing something right. Anyway, if it lights up, that is. Okay, here we go. I'm going to take it up to 60 volts. Well, nothing's happening so far. This is not cool. Uh-oh, what am I doing wrong here? What did I do wrong? Did I do anything wrong? Well, apparently I did something wrong. Let's go up to 80 volts. I should be getting a bulb by now, and I'm not getting one. Now, why is that? None of the tubes are lighting up? Well, that's not good. Am I getting power to this thing? I don't know. Let me find out. Well, we got ourselves a dead radio. Completely dead. Well, nothing lights up. Not the light, not the filaments, anything. Nothing coming out of the speaker. Oh, this is a great opportunity to maybe do some troubleshooting. What do you say? Huh? Let's do it. Okay, here's where logic and reason come in. I know I hooked all this stuff up because I took one out of each one and hooked it up the way it's supposed to go. And I know I've got this electrolytic jumped it in where it's supposed to go, but that wouldn't have mattered because we're not getting any power from this area here to the rest of the radio. So it had to have been something that you or I did wrong. Now what could it be? Well, if we know all of this is right, well, we're pretty sure, we're pretty confident it's all right, okay? About 99.999%, you know, has to be, because as we took one out, we replaced it immediately. And we only replaced two, this one and this one. So what does that leave us that we did underneath the chassis? Well, I think it left us with the power cord. Did I hook the power cord up properly? I don't know. Let's take a close-up and find out. Alright, let's check our connections. Well, one goes to the switch and then back out to the switch to this part of the transformer right there. I wonder if this wire here should have been hooked here instead of here. Well, I'll tell you what, let's go look at the videos that I posted, or in your case, if you didn't post a video, the photographs you took or the drawings you made. Let's find out if this wire right here was supposed to go here. Alright, check this out. This is the bottom of our transformer with the original connections. This one here is coming down from the switch, and it goes to the second one between these two. Well, son of a gun, I've got it hooked over here. Maybe we should move it back to here. Alright, moved it from here to here. Let's see what happens now. Alright, fire in the hole. Variac is on. Switch is on. Let's see what we get right here. Let's crank it up. We'll take it up to about, I don't know. Let's take it up 50 volts to see what happens. And about there's 50 volts or so. Almost no current draw. And looky there, we got ourselves a light. Successful troubleshooting, okay? Now, the question is, will the rest of the radio work? I don't know. I'm going to take it right on up. We're drawing almost no current. That's kind of bothersome. Let's take it on up to 90 volts. What is going on here? Why are we not drawing any current? This is not good. I'm going to take it on up to 110. No, I'm going to go all the way up to 120. We got a nice bright light. We should be drawing something. Look at that ammeter. Nothing at all. Very strange indeed. Okay, we're doing okay. The problem is I got a bad on-off switch here. I'm going to have to... Bad volume control. I'm going to have to play with that a little bit. Might just need another cleaning, I don't know. Yep, that's muffed up. Let me do a little cleaning underneath. See, it just went out again. Well, I went ahead and glued the light diffuser to this brass hub so I could use it to tune with. And it's doing okay, but it's coming and going. So it could be that those brass fingers down there need a better cleaning. Let me work on that and see what happens. If it doesn't fix it, that means I'm going to have to do a little more troubleshooting, and we'll see you in the next video. So let's see what happens. Our current draw is doing pretty good. It was a loose wire on that red thing over there. I retightened it back up. And for some reason, this thing just continues to come and go. I don't understand what it is. It's got to be this thing right here. I'm going to test that out between now and the next video. So this one is over, people. Could be the band switch, but I cleaned it twice. Turn up the volume. Doesn't want to hardly bring in anything. I don't know what the deal is. I will double check my wires underneath. I know they're right, but I'm going to double check them. But you know, these things are cantankerous like that. I remember the first radio I did of this model. God, I worked and worked. Of course, I didn't know anything in those days. I don't even know what to check. But it was just horrendous. It took me about a month, I think, of working on it almost every day before I even got sound out of it. So I'm going to check some resistors, some capacitors, and then I'll tell you in the next video what I find. And then we'll go ahead and correct it. I might even have a pot like this. A 500k ohm pot is what this is. Let me show you what that actually is underneath here. On these really old radios, these two connectors in the back are your on-off switch. Okay? Just these two right here. The rest of this mess, and this is the separation point between the on-off switch and the volume control. These three wires, this one, and this one, are your volume control. Everything it goes up and down on one side and up and down on the other. But this larger part of the switch and volume control is the volume control portion. These are a little bit tough to come by. The ones I have nowadays are very small. They're not anywhere near, but they work just as good. The biggest problem you have is, you know, with a small shaft, your switch knob won't fit too well. You have to make a few adjustments on that. So it can be done if I have to. If it turns out this is the problem, I might have one in my shop out there in my drawer. I don't know. If not, I know where to order one. I can get one from Radio Days. So until next time, and this is John. Meanwhile, I'm going to go ahead and change this capacitor and maybe this one down in here. I don't want to change, and maybe this one. These three. I'm not going to change these until you're back with me. So until then, this is John.